Researchers have succeeded in making an AI understand our subjective notions of what makes faces attractive. The device demonstrated this knowledge by its ability to create new portraits on its own that were tailored to be found personally attractive to individuals. The results can be utilized, for example, in modeling preferences and decision making, as well as potentially identifying unconscious attitudes. Researchers at the University of Helsinki and the University of Copenhagen investigated whether a computer would be able to identify the facial features we consider attractive, and based on this, create new images matching our criteria. The researchers used artificial intelligence to interpret brain signals and combine the resulting brain-computer interface with a generative model of artificial faces. This enabled the computer to create facial images that appeal to individual preferences. In their previous studies, the researchers designed models that could identify and control simple portrait features such as hair color and emotion. However, people largely agree on who is blunt and who smiles. Attractiveness is a more challenging subject of study, as it is associated with cultural and psychological factors that likely play unconscious roles in our individual preferences. Indeed, researchers often find it very hard to explain what it is exactly that makes something or someone beautiful. Beauty is in the eye of the beholder. The study, which combines computer science and psychology, was published in the IEEE Transactions in Effective Computing journal. Initially, the researchers gave a generative adversarial neural network GAN the task of creating hundreds of artificial portraits. The images were shown one at a time to 30 volunteers who were asked to pay attention to faces they found attractive, while their brain responses were recorded via electroencephalography (EEG). It worked a bit like the dating app Tinder. The participants swiped right when coming across an attractive face. Here, however, they did not have to do anything but look at the images. The researchers measured their immediate brain response to the images. The researchers analyzed the EEG data with machine learning techniques, connecting individual EEG data through a brain-computer interface to a generative neural network. A brain-computer interface such as this is able to interpret users' opinions on the attractiveness of a range of images. By interpreting their views, the AI model interpreting brain responses and the generative neural network modeling the face images can together produce an entirely new face image by combining what a particular person finds attractive. To test the validity of their modeling, the researchers generated new portraits for each participant, predicting they would find them personally attractive. Testing them in a double-blind procedure against matched controls, they found that the new images matched the preferences of the subjects with an accuracy of over 80%. The study demonstrated that the researchers are capable of generating images that match personal preference by connecting an artificial neural network to brain responses. The study may benefit society by advancing the capacity for computers to learn and increasingly understand subjective preferences through interaction between AI solutions and brain-computer interfaces.